bar plots and Simpsons Paradox, or why we should look deeper into the data. First, let's talk about bar plots or bar graphs or bar charts, which are some of the simplest types of graphs that we generally use. And bar graphs are usually for categorical data and usually focused on a single variable at a time, a single or at most two variables at a time. And let's remember that because we're dealing with statistics, we are interested in numbers. So even though we're working with a categorical variable like so-called number here, which has three potential values, none, small, or big, we're interested in the frequency as well, and the frequency here on the y-axis, and the three separate categories at three separate bars. And sometimes these will be colored differently. So within the same variable, in the same data set, this may be one may be blue, another green, another red, to kind of highlight the differences between them. But sometimes we'll do that when we usually have more than one variable. Now, generally, we have one or two variables in the same graph because if we start adding other variables, they usually they may have an entirely different kind of frequency range. So it's difficult to analyze them. But in the left side, we have the actual frequency count. And on the right side, we have the relative frequency counts. So what changed here, it looks like nothing really changed because the shapes look the same between the three compared among themselves. But here we see that these are the actual counts. So this is about maybe 500. Here's about 3,000 or so, which is kind of like what we saw before. And here about 500. And here's about maybe 15%. And here's about 70% and another 15%. And that's the relative frequency. Question for you. Why do the shapes of the graphs not change across these two here? We changed it from frequency to relative frequency. Why did the shape of the graphs among themselves did not change? I'll let you think about that. Now here we have segmented bar plots. So these include an additional variable. And we are focusing also on number, which has three categories. And forgive me for the nomenclature. Sometimes we have one thing with multiple names. Sometimes we have one name for multiple things. So one variable, three categories, or one variable, three values. Here's the count on the left side on the y-axis. And we also are depicting the type of the email. It's spam or not spam email. And so we're using the y-axis for the count. So here we can see that for not spam, it's all the way up to 500, and spam is somewhere here 150 or so. And the same thing for the other bars and within each of the categories. So within the none numbers, that is emails with no numbers, 500 not spam, and about 100 or so are spam. Now it's much easier here when to look at it when we have proportions. So here we clearly see that about 25% of emails that have none are spam, and then 75% of the emails that have none numbers are not spam. And notice how the category or the range here really changed between these two graphs, between the actual count and the proportions. Because we're dealing with two different separate variables, we need to use proportions, otherwise it's not going to be able to, we're not going to be able to compare them. And we can see that, as we saw on the numbers before, nones have a much higher rate of spam than actually this areas with a small number or with a big number. Pie charts. Pie charts are not generally recommended to use in statistical analysis, although they are very common in various contexts. So here, I just wanted to mention that we need to be careful with pie charts, potentially not use them at all, because it's really hard to compare the categories when we're using a pie charts, and there are several examples here. So let's just take a look here. A, if you see, it's difficult to see if this chunk here, 5, is really much greater than 4. Could be, but it's not clear. It's not clear that 4 is greater than 3 or 3 is greater than 4. It looks like 5 is greater than 1, but is 5 greater than 2, and how much greater? When we put it in a bar chart, it's much clearer to see that, oh yeah, 5 is actually substantially higher than 2, although the same is not the case here. And you can see here on the different examples as well. So generally, let's use bar charts instead of pie charts. Lastly, let me talk about the Simpsons paradox, or the need to examine the data deeper. And there's a very interesting case here as explained in the textbook. So we're talking about data on sentencing for two types of people, Caucasian and African Americans, and focusing first on the defendants. And let's call it aggressor, because defendant almost sounds like victim, but defendant is the aggressor. And whether these people received the death penalty or no death penalty. So only 2 values for sentence and only 2 values for defendant's race. And these are just absolute numbers. They're not proportions. So let's look in the graph for the proportions. And what we can see here is that it seems that Caucasians, in general, in relative terms, receive more death penalty than African Americans. It's not much, but it's some. It's about 24% of Caucasians receive a death penalty, whereas maybe 18% of African Americans receive the death penalty. And then if you know that this domain, you will say, wait a minute, I know that there is a lot of discrimination and racism in the criminal justice system in the United States. So what's going on here? Is this really the case, or are there any confounding variables? Well, this data is true. This data is real. And when we look at it just at the defendant's race, we see this. The problem is that another relevant variable that is impacting these results that we're not looking at is the victim's race. So when we start looking at the victim's race, we see that, let's focus our attention on the left side for Caucasian victims. So the left bar is African Americans, when the African American is the aggressor. So when the African American is the aggressor, about 25% of them get a death penalty for Caucasian victims. However, if the aggressor is Caucasian, only 12% get the death penalty. So this is double. This is much. There's a big difference, and it's much worse for African Americans. Almost twice as much they receive the death penalty than Caucasian when the victim is Caucasian. Now let's look at the African American victims. Well, actually, we also see a difference that African Americans, although it's much smaller, African Americans also proportionally get much more death penalty than Caucasians. Caucasians seem to get no death penalty when the victims are African Americans, but when the victims are African Americans, African American, when they are the aggressors, they do receive death penalty, at least, maybe, what is this, 10% or so. So in both cases, for both victims, we see that the rate of death penalty is much higher for African Americans. And that's why we call the paradox, because from the previous data, it looked like Caucasians receive death penalty much higher, or at least slightly higher than African Americans. But it's not really a paradox. It's just that we're looking at the data in different ways, different views of the data, and we're highlighting or hiding different variables and characteristics of the data. And to understand this further, if we break down victims' races versus defendants' race and graph that, we'll see that if the victim's race is African American, usually the defendant's race is also African Americans. Right here, it's much larger. It's about 75%. It's kind of same thing, but inverse for the Caucasian. So if the victim's race is Caucasian, then the defendant's race most of the time is also Caucasian. So we definitely see that this is a potential factor here. And also, perhaps most importantly of all, focusing on victims' races versus sentencing. So when the victim's race is African American, when the victim's race is African American, the proportion of death penalty is very small, it's tiny. But when the victim's race is Caucasian, the proportion of death penalty is much higher. It's still only about 12%, but it's much higher. It's at least 3 or 4 times higher than when the victim's race is African American. So what's happening is the victim's race, if the victim's race is African American, there's much less death penalty. And also we notice that, well, crimes are also committed mostly by African Americans, within African Americans, and by Caucasians with Caucasians. So this helps explain why the death penalty was much lower here in the African Americans defendants in this graph. So the point here is that we often need to look for confounding variables, for other variables that are impacting the results that we have, other variables that help clarify and understand the domain or the set of relationships that we are interested in. And that's it for this one, and I'll see you next time.